Hello everyone. In this lecture, we have discussed on the elimination addition mechanism. In the last lecture, we have discussed about the addition elimination mechanism. Now, benzene intermediate mechanism. What is a benzene? What is a benzene? Benzene, it is a neutral, highly reactive intermediate. Benzene. This is the structure of the benzene. This is the structure of the benzene. It is a neutral, highly reactive intermediate in which the aromatic characters are not disturbed. In which the aromatic characters are not disturbed. The benzene bond is not like the triple bond. The benzene bond is not like the triple bond, like the acetylene, the carbon-carbon triple bond, the structure of acetylene. Okay, the benzene bond is not like the triple bond of acetylene. Here, bond is formed by this bond, the triple bond. The bond is formed by the sidewise overlapping. So, sidewise overlapping here of sp2 orbitals of two adjacent carbon atom. This is a sidewise overlapping of the sp2 orbitals of two adjacent carbon atoms. This new bond form, this new bond orbital lies along the sides of the ring. This new bond orbital lies along the side of the ring and has a little interaction with the pi cloud lying above and below the ring. There is an interaction of this pi cloud, the pi cloud lying above and below, okay, above and below the ring. Since the sidewise overlapping is not a very good, the sidewise overlapping is not a very good, the new bond is a weak, this new bond is a weak, and hence benzene is a highly reactive molecule. So benzene is a highly reactive molecules. Here, the sidewise overlapping of the sp2 orbitals of the two adjacent carbon atoms, okay, then to form the pi bond outside the ring and out of the plane of the pi system of the ring. They are the two pi bonds, okay. One is outside the ring and one is inside the ring. The formation of benzene is an elimination addition reaction. The formation of benzene is an elimination addition reaction. Benzene may be regarded as highly strained acetylene. The benzene may be regarded as highly strained acetylene. These are the two unstable to be isolated and react with any nucleophilic present in the solution. These are two unstable to be isolated and react with any nucleophilic present in the solution. Now here the reaction is given. Okay, the aromatic nucleophilic substitution can also occur by the elimination addition mechanism. The aromatic nucleophilic substitution can also occur by the elimination addition mechanism. Already we discussed the elimination reaction and addition reaction. What is the elimination? The those reaction in which two atoms or group attached to the adjacent carbon atoms are eliminated without being replaced, these are called as a elimination reaction. What is the addition reaction? The addition reaction is a takes place across the carbon-carbon double bonds. The addition of the reagent across the double or triple bond of an unsaturated molecules. Okay. Now, this is a elimination addition reaction. There are the two steps. The first, the eliminate the uh, hydrohalogens, okay, hydrohalogens, and then after the addition of the strong base. Okay, they are the two steps. This type of mechanism is elimination addition mechanism is followed by the when the nucleophile is a strong base. Nucleophile is act as a strong base, okay, such as the amide, this NH2 minus, such as the amide ions in the form of the soda amide, or potassium amide. The strong base amide is in the form of the soda amide, means NH2 or potassium amide, KNH2. The reaction is given when the chlorobenzene, the structure of the chlorobenzene is a reaction with the soda amide, is a reaction with the strong base, soda amide, in presence of the liquid ammonia, in presence of the liquid ammonia at a temperature minus 33 degrees Celsius. The chlorobenzene is a reaction with the soda amide or potassium amide in a liquid ammonia at a minus 33 degrees Celsius. Then the formation of aniline. Then the formation of aniline plus sodium chloride, plus sodium chloride. This reaction takes place by the formation of benzene as an intermediate. This reaction takes place by formation of benzene as an intermediate. Now, the amide means NH2 minus. Amide ion is, which is a very strong base. Amide ion, which is a very strong base, brings about the dehydrohalogenations. Brings about the dehydrohalogenation. What is the dehydrohalogenation? That is a removal of the HCl. Removal of the HCl. Okay, removal of HCl means removal of hydrogen halogenations means dehydrohalogenation, removal of HCl like HBr, HI. Okay, the amide ion is a very strong base, brings about the dehydrohalogenation of chlorobenzene. Means in this reaction, the removal of the HCl. The proton is the first. Now the structure of the chlorobenzene. Okay, you draw the structure of the chlorobenzene. This is a chlorine, and the proton is a adjacent to the chlorine. Okay, proton here. Okay, the proton is the first abstract. Okay, now the amide ion which abstract the first the proton, which is adjacent to the those carbon atoms which bearings the chlorine atoms. Okay, the proton is the first abstract from the carbon which is adjacent to that carbon atom which are bearing the halogen atoms. The NH2 minus is abstract the protons which abstract the proton from the carbon which is adjacent to that carbon atom which bears the halogen atoms. Okay, then the halogen, now NH2 minus abstract this proton. Now here the negative charge is present on this carbon atom, that's a carbanion. Okay, like that. Here the chlorine. Okay, now the negative charge, when the amide ions abstract this proton, the negative charge is present on this carbon atom. This carbon, which is adjacent to that carbon atom which bears the halogen atoms. Okay, now the negative charge present on this carbon atom. Again, the here the one double bond already present. Then again this here the lone this negative charge is shift here. Then this bond is a remove. Okay, this chlorine here the remove. Then the formation of the benzene. Then formation of benzene. Then the halogen is abstract to form the unstable intermediate. Unstable intermediate is formed, is called as a benzene. Is called as a benzene. Now, in the second step, the amide. In the first step, the formation of benzenes. Okay. In second step, the amide ion acts as a nucleophile. Amide ion is a strong base which acts as a nucleophile and adds to one of the carbon atom of triple bond. They are the two. This is a carbon-carbon triple bond here. Okay, they are the two possibilities. Okay, the amide is attached both the carbon atoms. Okay, the amide ions acts as a nucleophiles and adds one of the carbon atom of the triple bond. One of the carbon atom of the triple bond, then to form the carbanion. Then to form the carbanion. What is the carbanion? Carbon carries a negative charge. Now suppose the NH2 minus is attached this carbon atom, then this bond is break in the direction of this carbon atom. This carbon carries a negative charge. Then here the formation of the carbanion. Formation of the carbanium in the second step. In the next step, what happens? The aryl, this carbanion, again, the aryl carbanion then extract the proton from the ammonia solvent. This carbanion is extract the proton extract the proton from the ammonia solvent. Ammonia is as a solvent in this reaction. Now this carbanion extract the proton from the ammonia. Okay, then to form the ammonia here. Then to form the ammonia. Now this hydrogen is attached to here that carbon atoms. Then the formation of the aniline plus NH2 minus. These are the three-step mechanism. Okay, the benzene intermediate mechanism. First the elimination, then after the addition of the amides. Okay, that means the addition of the NH2 group. In the first step, the formation of the benzene, that is the elimination of the dehydrohalogenations, and in the second step, the addition of the amide to the benzenes, then the formation of carbanion. Okay, again this carbanium extract the proton from the ammonia, is used as a solvent in the reaction, then to form the aniline. Generally, this reaction, the chlorine is replaced by the NH2. Chlorine is replaced by the NH2, then to form the aniline. Okay, thank you.